Suppose you want to solve a linear program like this linear program here. If you don't know what a linear program is, don't worry, just check out my video about this. The link is in the description below. Now, you could of course solve this linear program by hand, by running the simplex algorithm by hand, for example. However, it's of course much better to use your computer to solve this linear program. And this is what we're gonna see in this video. So by the end of this video, you will know how to solve such a linear program with Python. Before we can talk about solving a linear program with Python, we have to talk about one very important thing, which is the solver. Why is this? Python, as it comes, cannot solve linear programs directly, but instead what you need is a solver that solves your linear program. There are actually many solvers for linear programs. For example, Gurobi, Cplex, FICO Express, CBC, GLPK, Skip, and Heise, and many more. These solvers come in two categories. Some of them are commercial solvers and some are free solvers. The difference is, guess what? You have to pay for the commercial solvers and you can use the free solvers for free, even for commercial applications. Normally, commercial solvers allow you to get a free so-called academic license that you can use, for example, for your master thesis and your PhD thesis. So there you can use these solvers actually for free if they have such a license. However, you cannot use this license for some commercial applications in some company that you work for. In this video, we will use the free solver CBC, but actually everything I will tell you works equally well with any of the other solvers. So before you can solve a linear program with Python, you have to install your solver like CBC, for example. I put a link in the description below to some instructions how to install CBC on your computer. And this, of course, depends on your operation system, whether you have Windows or Linux or Mac OS. The second thing we need is a modeling framework. Why do we need such a modeling framework? Well, the reason is that on the one hand, you have your Python program right here, and on the other hand, you have your server like CBC, and they cannot talk directly to each other. Therefore, in the middle, you need a modeling framework such that your Python program inputs the linear program in the modeling framework, and your modeling framework gives this linear program then to the solver, and then the solver gives the solution back to the modeling framework, and therefore you can use this solution in your Python program. There are actually several modeling frameworks, for example, Pyomo, Pulp, PythonLib, and many others. In this video, we're going to use Pyomo and therefore in particular use the syntax of Pyomo. However, you can also use any other of these frameworks that you prefer. Before you can use Pyomo, you have to install it, and also here I put a link in the description below. Alright, so now let's get started and code our linear program with Python, Pyomo, and CBC. So this is our linear program that we want to code now. The first thing is, like in many Python programs, we import something. In this case, we import Pyomo and import Pyomo environment so that we can use it in our program. Secondly, we create a new linear program with this line here. So program is our linear program. Please don't worry about concrete model. There are also other models in the Pyomo framework, but let's just go with this being our linear program. Then we need to model our variables. Our variables are x1 and x2, and we do this by writing program.x because we want our variables to be called x1 and x2. And we write here pyo for pyomo.var for variable. 1, 2 means that the variables come in a range from 1 to 2 because we want to have the variables x1 and x2. And here I write domain equals pyo.non-negative real. This ensures that for our variables x1, x2, we automatically have this greater or equal than 0 constraint. And if we wanted to, we could also add constraints that say x1 greater or equal than 0 and x2 greater or equal than 0. However, it's more convenient to write this directly here in the domain. Then everything becomes more compact. Good. Next thing we need to define are our constraints. So let's start with the first constraint, 2x1 plus 3x2 less or equal than 18. And the way to write this is right here. We had program.constraint1. So in order to define our first constraint, and in order to define it, we write pyo.constraint, and this expression, expr, is exactly what our constraint is. So 2 times program.x1, because we want to refer to the variable x1 in our program, plus 3 times times program.x2 is less or equal than 18. Similarly, we define our second constraint for x1 plus 3x2 less or equal than 24 by simply writing this line here. So we define our constraint 2 to be the expression of this constraint is 4 times program x1 plus 3 times program x2 less or equal than 24. Now, we're not done yet. For example, we haven't yet defined our objective function. So therefore, let me move our program up. So the next thing we want to define is our objective function, which is to maximize x1 plus x2. And we do this by writing this line here, which is program.obj. So obj is intuitively an object that refers to our objective function. And we define it by Pyomo.objective. And in this expression here, we write our objective, which in our case is x1 plus x2. And therefore, we are program.x1 plus program.x2. And here write sense equals Pyomo.maximize because we want to maximize this objective. If you have a minimization objective, you just write sense equals Pyomo.minimize. Good. Now we define the linear program. Now, of course, we want to solve it. And how do we do this? Well, first we have to instantiate our solver object. And for this, we write solver equals Pyomo.op.solver factory. And here I give CBC as a parameter. So this generates me a solver object for my solver CBC. And if you want to use a different solver, then you don't write CBC here, but the name of the solver you want to use, like Gurobi, Cplex, etc. Of course, you have to make sure that you have the solver installed in your system. Otherwise, you cannot use it and you will get an error message. Good. Then, last but not least, we actually solve our linear program with this line here. So we write solver.solve. And as a parameter, we give it the program that we want to solve. Okay, so now our solver solved our linear program. However, this is not yet that useful because we want to get the solution back into our Python program and then do something with it. So let's see how we can do this. It's actually very easy. If you want to get the value of the variable x1, for example, you write program.x1, that's our variable, .value. And this is a number. So here what I do is I convert it into a string so that I can print it. Similarly here, I get the value of x2, convert it to a string and print it. And here also very similar, I write program.obj. Recall that obj is the objective function that we defined. And this gives me the value of this objective function. And here again, I convert it to a string and print it out. So now let's run our Python program. So here you see its complete code. And if I execute this code, what happens is I solve my linear program and I output the value of my variable x1, which happens to be 3. I output the value of my variable x2, which happens to be 4. And I output the value of my objective function of this solution, which is 7. So now you know how to solve a linear program with Python, Pyomo, and CBC. At least a linear program that is given by a fixed set of variables and a fixed set of constraints. You might know that there are other linear programs where, for example, you have one variable for every vertex of a given graph or one constraint for every edge of a given graph. However, for this we need another video.